name is Misty, and I'm here to introduce you to welding. Yay! All right, so this lecture, it's going to focus on a couple of different things. We're going to focus on the major welding processes or different types of welding, factors when we consider a welding process or type of welding, the history of welding, and different terms like forge welding, resistance welding, fusion welding, coalescence, and especially certifications. All right, so we have some terms that are associated with welding that maybe you're not very familiar with, but let's get familiar. The AWS, or the American Welding Society, it's been around for about 125 years, and they're responsible for creating codes, standards, and rules for welding. Many buildings actually reference a type of code and standard that's set by AWS. Automated operation. This is where welding is performed by a robot or machine and is programmed by a welding operator or actual human. Automatic. This type of welding is performed by a robot or machine but doesn't require any interaction from a human. Manual operation. This type of welding is done by hand. Semi-automatic. This type of welding is done by hand but uses a gun that has a trigger that feeds the wire or electrode for use. And we'll also talk about different types of welding processes as well. All right, so here we go. So let's talk about welding and joining throughout the ages. Early methods of joining metals used sand to make a casting. A piece of metal was placed on the bottom and a mold was created from sand, and molten metal is poured into the sand. If you want to learn more about this, you can look for, it's on YouTube, it's called The Amazing Cast Iron Process in the Factory. And it actually shows how they make cast iron from India still today, okay? All right, let's go forward. There's also a different type of metal joining method that was used as well, but in kind of a different way. Two pieces were joined using a sand dam, and then the molten metal was poured into the sand. Okay, and if you really are curious about something like this, you can also watch another video on YouTube, how they use sand and when they make repairs on railroad ties with thermite and sand molds. All right, so now we can see that about 1500 years ago, China was using welding. You know, they're ahead of us and everything. All right, so the Industrial Revolution was from about 1750 to 1850. This is where welding started to come alive, and there was forge welding or hammer welding. So what would happen is two pieces of metal were heated up so they were soft, and then they placed the end where they wanted for them to be joined, and they repeatedly hit or hammered it. So ultimately, these types of practices use an actual flame. Okay, so as techniques developed, electricity was starting to use it. In fact, electricity being developed, and it replaced riveting. Riveting only allowed for buildings to be made in a box shape. Really difficult to construct and very, very time consuming and costly. Okay? But when welding came along, welding allowed the joints of the building to become any shape at any height. This built our skylines in our country. Okay, so let's talk about some welding terminology. Some terms can be used by welders, and you might need to know what they're saying. All right, so let's get to saying. Oxyacetylene welding, or OAW, is from a group of welding called Oxyfuel gas welding. Oxyacetylene notes that oxygen and acetylene gases are being used to weld. Some of the names like gas welding or torch welding, that refers to OAW or even Oxy, okay? So here's another type of welding that can be called something different than we think. Shield Metal Arc Welding, or SMAW, can be called stick welding or just welding. All right, so this is gonna be a little tricky, so listen carefully. So what is welding? The American Welding Society defines welding as a localized coalescence of metals or nonmetals by heating the material with or without pressure alone, and with or without the use of filler metal. So what did I just say? Blah, 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 right? Okay, so in English, it says that welding is where a piece of material, like metal, can be heated up and we can squeeze it together to make one piece. We can do this just with pressure, without pressure, with the need to fill it with more material like metal. So, in other words, welding is the highest form of gluing metal together. Yay. All right, here we go. Uses of welding. What can we do with welding? Look around the room, okay? Most items you look at, they're welded, okay? That hard plastic packaging that you can never get open, well, it was plastic welded using ultrasound. Okay, so the chairs we sit in or the electronics we use all use some kind of welding, okay? Ships, automotive, aerospace, and even roller coasters are welded, not to mention our spaceships, anything that's going to go into outer space. And check this out. This is a welding machine meant to be used in space. This is really cool, right? So this figure shows Svetlana. I can't say her last name, so I'm not going to try. She's the first woman to actually use a welding and cutting machine in space. It's super cool. So much can be done with welding. Okay, welding is used in so many different industries. Let's try to name it. Agriculture, aerospace, racing, farm equipment, cars, computer components, construction equipment, railroads, and so many other industries. Okay, so let's talk about different welding and cutting processes. Okay, most welding processes use the basic theory of heating and applying pressure, or just heating it, or just pressure, and different variations of that. Okay. Currently, and this form is a little bit old, there are 121 different types of welding. This doesn't include any of the newer technology that has been coming recently. Okay, so here it is. This is a lot of welding and joining processes, and we're only going to talk about a couple of few. Okay? So here we go. Their most popular processes are Oxyacetylene Welding, OAW, Shield Metal Arc Welding, SMAW, also known as stick welding. Gas Tungsten Arc Welding, GTAW, also known as TIG welding, or you got an old-timer Arc Welding. Gas Metal Arc Welding, GMAW, or MIG welding. Flux Cord Arc Welding, or Flux. Okay. There are two very popular cutting methods as well. OAC, which is oxyacetylene cutting, and PAC, plasma arc cutting. Okay, so we're going to start out by learning about oxyacetylene welding, cutting, and brazing. This is grouped into oxyfuel welding and cutting. Essentially, the same equipment with small changes can be used for all of these processes. They use acetylene and oxygen gas, a pressure regulator, hoses, and torch bodies. The tip of the torch body can be changed for what you're trying to accomplish. A cutting head can be put on if we're going to cut metal. A welding tip can be used to weld or braze metal. Okay, so the most common fuel gas for this is acetylene, but this is just not the usual is acetylene, but there can be different combinations of this, okay? So usually it's a combination of oxygen and a fuel gas, okay? And you can cut or weld with propane, natural gas, MAP gas, and some other ones, okay? Hence the larger group of named oxyfuel welding and cutting. Okay, next up, shield metal arc welding. Woohoo, the good stuff. Shield metal arc welding or stick welding. SMAW use a consumable electrode. Consumable, it means that it gets used. Electrode, meaning that it conducts the welding current. So the electrode has a flux covering that vaporizes and protects the weld while it solidifies. So if we look at this, ultimately in a very basic way, SMAW completes a circuit. When it completes the circuit, the electrode that's carrying the electricity creates heat and melts itself and the base metal. Pretty cool, right? All right, onward! GTAW, or gas tungsten arc welding, TIG welding, or Heli arc welding. This was first created to weld aluminum and metals that weren't steel. Okay. TIG uses a non-consumable electrode. Non-consumable means it does not get made into the weld. Electro meaning what? It conducts the welding current, and it is made out of tungsten. The arc that is created by the tungsten melts the end of the filler metal and the base metal, and the filler metal is dipped into the molten weld pool by hand or manually. Okay. Additionally, there's no flux that's used in this process. A shielding gas must be used to protect the molten weld pool until it solidifies. This is a very detailed type of welding and is one of the cleanest manual processes. We use this for aircraft and even some medical devices. Okay. GTAW, though, it's slower type of welding because of the required skill level to use both hands and a foot or finger control at the same time. And it's really in demand because mission critical parts can be welded with precision. All right, gas metal arc welding. Gas metal arc welding, or MIG, this uses a solid electrode that is fed from a spool through a cable and into the welding gun. GMAW requires a shielding gas to protect the molten weld pool, and the gas flows through a cable and into the gun nozzle where the wire and the gas come out together. So ultimately, the welding current flows through the electrode wire and melts it. GMAW is very fast and economical because there's no need to replace a welding rod since the wire is on a spool and it can be fed quickly for long welds. There's also very little cleanup since there's no slag. Onwards, Flux Arc Welding. Okay, FCAW process uses an electrode wire like GMAW, but this wire has flux on the inside of the wire. The wire then can be fed in the same way like GMAW. The filler metal and the base metal, because of the current going through the electrode wire, are melted. But there's no need for gas because that flux that's inside the wire, it vaporizes and creates a shielding for the molten weld pool. FCAW can be used in place of SMAW. While there is still slag that must be cleaned, it has become more cost efficient and faster than SMAW. All right, so let's talk a little bit about cutting processes or thermal cutting processes, thermal meaning heat. Okay? So, Oxyfuel Cutting and PAC, or plasma arc cutting, are the most common thermal cutting processes you'll come across. There's also air carbon arc and even laser beam cutting. Oxyfuel cutting uses the oxygen and the fuel to create a flame. A stream of oxygen then is pushed out and it is used to cut through the steel. The limitation though of oxyfuel is that it can only cut most types of steel. While this is still very useful, portable, and a very common tool, it is inexpensive to use on most materials. Plasma arc cutting. Woohoo! Plasma arc cutting uses a plasma electrode to create an arc, and a stream of compressed air or gas is forced through an orifice to make a cut, which is really cool. PAC, though, must use a compressor or compressed gas as well as electricity. This can cut just about any type of metal that can be cut. The drawback, though, is that most compressors and compressed gases and enough electricity aren't very portable. All right, so how do we select a type of welding or joining process? Well, let's talk about it. Sometimes as a welder, you must decide the most appropriate welding process to get the job done. So here are some factors that you need to take in consideration. When there's no real rules for this, but you need to take some of these things in consideration. So we're going to go down and kind of ask some questions of ourselves. So what is the availability of the welding process, the type of welding? Do I have the machine already? Or if not, is it too costly to purchase the machine. Okay? Will I have to repeat the weld several times, or is this just one weld? Where is the location of the work? Is it going to be in shop? Is it going to be on the field? Is it going to be on the ground floor, or is this on the top of a building? If it's on the top, do I have availability to cords, cables, and electricity for the process that's necessary? Or is my machine even portable? And then we have to think about, well, what types of materials are we going to be welding? Is it steel? Is it an alloy? What does the weld need to look like? Okay. How big are the parts, or how long is the part that needs to be welded? Am I welding on a building, or am I doing just a little half-inch weld? How much time do I have to complete the welds? Is it a day, a week, a month? How many do I have so I know exactly how big this project is? What is the skill level of the welder? Can the welder do this? What is the cost of the particular materials? And are there specific codes or standards that must be taken into consideration? Under those codes, you may need to be certified to the particular code in order to perform the work. So now, many times when you're working with a company, the engineer will decide the welding process. But sometimes you need to be able to find out what is most appropriate. Welding and cutting can be performed in manual, semi-automatic, automatic, and automated versions. So many people want to know, what are my opportunities in welding? Your opportunity is endless, okay? There are so many different industries that use welding. Your door opens once you become a welder. And here's some of the things that they might be calling a welder. A welder, a tack welder, a welder helper, a welder fitter, a welder pipe fitter, a welder assembler, a welding inspector, a shop owner, welding engineer, and there's so many more. Okay, but here it is. The highest paid welders are those guys who have the education and know-how and can read blueprints. Okay. Other types of workers that can be laying out materials, all sorts of different things. Okay. Usually, though, training, it takes several months to learn how to weld. Welding is a skill because we want to have to learn how to do it. There's no set time to learn welding, but just like there's no set time for learning to tie your shoes. Okay? It's important to learn to weld as well as understand the science and why of welding. Because welding is so diverse, there's no one skill set that can be used to meet every job requirement. However, there are some basic skills that you might want to think about making sure that you have. Okay? So, here it is. Job-related skills. All right. Teamwork, leadership, integrity, honesty, time management, organization, good eyesight, manual dexterity, understanding and knowledge of welding technology, blueprint reading, basic math, measurement skills. This list really isn't all-inclusive, but it hits on some of the major stuff. All right, so what do I do to begin? Well, most beginners start off in a welding position that requires a minimum of skill, so an entry-level job. Okay. Some industries, like aerospace and pressure vessels, they require more skill and technical knowledge that is gained through more training and experience in the welding industry. After you've gone through the training, you can also become certified in a particular type of welding process with the American Welding Society. As your skills grow, you can qualify in different types of positions, such as welding technician. All right, well, we have to tweak green as well. We need to realize that welding and cutting processes, they use a large quantity of energy and material. So we want to make sure that we're being a steward of the environment and making sure that we are trying to recycle some of the stuff that we have. All right, so practical knowledge. Well, there are going to be 3 different areas covered. Actually, more than that when we talk about this, but we're going to go through a bunch of different sections, and this is how the curriculum is broken down. The first module is an occupational orientation, or, hey, what's welding? Module 2, safety and health. Module 3, Drawing and Welding Symbol Interpretation. This is blueprints, okay? All right, as we go further down, we're going to work on thermal cutting processes like Oxyfuel Cutting, Plasma Arc Cutting, okay? So these are the chapters in our book. Okay? And then, of course, Module 9 also talks about areas of inspection, how to prepare parts, and what they're looking for in the job. Skills USA. Well, this is pretty fun. Skills USA is kind of like the Olympics of welding and the Olympics of vocational training. Okay, they use it from all sorts of different areas and in all sorts of different industries like engineering, drafting, welding, plumbing, and everybody goes and competes in their skill. Okay, very cool. All right, overall, welding is a really diverse trade. Okay, there is so much that is made with welding. It is endless. And then we also know that we can make anything. So this is just a beginning.
Weld the world.